All right, ladies and gentlemen, today we're going to be looking at lesson 3.1. Our main goal, the objective, is I can simplify an expression by combining like terms. Combining like terms is going to be super important for us. So let's see how we can do this. I know this looks a little silly, but we are going to combine like fruits. Now, don't write it down, but our simple discussion is if you have 4 apples, and look over here, 3 more apples. So it's kind of like when you go to the grocery store, you can only put apples in one bag, oranges in another bag, bananas, you really don't put those in bags, right? But again, the idea is they have to be similar or considered alike to be able to combine them. So I don't really make my students reorganize it and put 4 plus 3 apples. I just say, let's do the commutative property of addition. So I can move it around if I want to, but I think I can just look at 4 and 3 and add it to get 7 apples. Same thing with bananas. 3 plus 2 is 5 bananas. Now I cannot add those together, even though they are both a fruit. I need to keep them separate, and that's going to be key here. All right, what we have here is an idea of not only do they have to be the same variable, but they also have to have the same exponent. So if you notice, you got coefficients here. That's just a fancy word of saying the number in front of the variable, the beginning of the term. And then you've got that constant, that number at the back where there's no variable at all. It's by itself. Remember, you can pause it, back it up if you need it more time for the notes. So those like terms, not only do they have to have, again, the same variable, it has to have the same power or same exponent. So in other words, an x and an x squared are not like terms. Again, the constants, no variables, I can combine those. So for our like terms, if I look at it, just going from left to right, my 5x is going to match up with my 12x. Because again, they have the same variable, same exponent. What about my 8y? Anything? Oh, nothing there, right? The y is all alone. That's so sad. What about the 9z? If you scroll across, yeah, the 14z. Same variable. The 10 and the 7 match up. The constants, no variables. X squared and 3x squared match up. Definitely. Same variable, same exponent. So what we're going to be doing at this beginning part of your assignment, so you have problems in your homework or the textbook just like this. You got it all nice and horizontal. We're going to go ahead and combine our like terms. I like to go ahead and identify them first. So the terms, obviously, so you don't have to write this out because it's already got the terms there. The like terms, though, 3y and negative 4y. So I'm actually going to change that into a box. I prefer, instead of underlining, because that's the way I used to teach it, but man, so many underlining required. All right, so I've got 2 boxes, rectangles, if you will. Notice I got the sign there. Those are like terms. And then definitely the constants are remaining a negative 2. Notice the negative sign got in there, and the positive 6. So I go to box, circles, and then if I need more, triangles, or maybe a star or a cloud. Some people do hearts. So at the beginning, we're just asking you to identify the like terms by shaping it. Does that sound? Yeah, by making them shapes. So we got terms and like terms. So again, the terms those are all those pieces there. So let's go ahead and jump to the like terms. All right, I'm going to change that into a box. Now here's the key. Put a little 1 there. You'll see why in a bit. And then negative 7, a W. Got to call it W. Those are like terms. Plus 5w squared and plus 2w squared are like terms. And then obviously the negative 9 is all alone. It's so sad. No like terms for that. Simplify the expression. So not only are we going to do the shapes, but we're also going to combine them, kind of like we talked about the apples and bananas. So I'm going to go ahead. Oh, let's change those to boxes. I've got a 6x and a negative 5x. Well, what does that give me? Remember, I'm just going to really add or subtract. And then I got a positive 4 and a negative 7. So if you notice, it's very similar to those integer rules that we did back at the beginning of the year, chapter 1. We also talked about them in fraction form in chapter 2. Now in chapter 3, using the exact same skills, but with variables this time. So a 6x and a negative 5x, well, that just gives me a 1x, or we write it as x because the 1 is hidden. And then a 4 and a negative 7, that just gives me a negative 3. Now remember, you cannot combine the x and the negative 3. Those are unlike terms, so I'm done there. Ooh, on this one here, notice how I have to distribute. So I'm going to say the k is going to stay the same. Let's don't circle that, so ignore that. Let's just do our distributive property. Negative 2 times e is negative 2e. And negative 2 multiplied by negative 3k, negative multiplied by negative is positive, 2 times 3 is 6, so positive 6k. Now that I have it looking like the previous example, I'm going to go ahead and do my boxes and circles to help me with my like terms. Now remember, we said 1k. Now that's okay for work, but not an answer. And 6k. Well, 1k plus 6k is 7k, and the negative 2e tags along. Now remember, please don't try and put these together. Those are unlike terms. Another way you could write it, though, would be negative 2e plus 7k, because 7k is positive. I'd accept that. Oh, fractions. But we're going to do our awesome skill here. So again, distributive property. Negative 1/2 times 6p, so a negative times a positive is negative. Half of 6 is 3, and the variable just tags along. And then we have a negative 1/2 times 4. Well, a negative times a positive is a negative, and half of 4 is 2. So I have a negative 3p, negative 2, and positive 2p. So my like terms, remember, hey, circles this time. You can use stars, hearts, clouds again, a fish if you want. It really doesn't matter. It just needs to be the same because, again, they're called like terms. So negative 3p plus 2p is negative, well, we don't say 1p, just negative p, subtract 2. So again, that little 1 is okay for work, but not for your answer. So let's try and work on that throughout the year. All right, we just got a few more. I know we're going kind of quick. We got a really short day today. Find the area. Now we know the area is simply length times width. And if I say 8 times 7 subtract x, hey, I just got to do my distributive property, right? 8 times 7, no need to circle it, is 56, and 8 times negative x is negative 8x. Now we should know these are not like terms, so don't even go ahead and combine them. So I'm not too sure why this problem was in our section, but I think it's getting us ready for the next one. So that's the area. I think the next problem is key, because the next problem we're going to talk about, well, we'll get to it soon, perimeter. So on example 8, not the perimeter problem, example 8, it says, each person buys a ticket, a small drink, and a small popcorn. So each person does that. Write an expression in simplest form that represents the amount of money the group spends. So maybe your group is 10, another group is 50. So the tickets are $7.50. The drink, small drink, is $1.75, and the small popcorn is $3. But remember, each person buys it, so we're going to represent it as $7.50 x, because x represents the amount of people, plus $1.75 x, because again, each person's buying it, so yeah, they are like terms. And then 3x, because the small popcorn's $3, each person's buying it. Hey, these are all like terms, so I can go ahead and combine them, add them up if you will, and it'll give me 12.25x. So if you want to, again, you could put a box around all of them. But some of you are like, but Mr. Murillo, they're all the same. Why would I do that? Because you can. Because they're like terms. 12.25x. So if your group had 10 people, you would just multiply by 10. If your group had 50 people, you'd multiply by 50, and so on. If your group had 1, you multiply by 1. All right, here's the one. We're going to end with this. Find the perimeter. Now, there's a few ways to find the perimeter. Based off of elementary school, we know if 4x is on the left, then 4x is on the right. If 3x subtract 1 is at the top, then 3x subtract 1 is at the bottom. Now, if you notice, there are like terms. X's are like terms. You could add them, because again, the perimeter is just adding all the sides. And then you can add your constants together. If you'd like to, you can try this formula. Again, that's a little bit more 7th, 8th grade situated instead of elementary. Because a rectangle, we know that we have 2 equal lengths and 2 equal widths. So it's 2 multiplied by 4x plus 2 multiplied by 3x subtract 1. Now remember, we said you could add up all of the outside if you'd like to, like terms though. The formula gives me 2 times 4x is 8x. And then distributive property, 2 times 3x is 6x, and 2 times negative 1 is negative 2. Combining my like terms, I'm going to change those to boxes. I can add them together. Wait a minute, isn't 8x, again, 4x plus 4x? And 3x plus 3x is 6x, so I knew it. Yeah, you could keep using the elementary style if you'd like to, but don't forget, again, on elementary style, negative 1 and negative 1, adding those gives us negative 2. 14x subtract 2, but our units are inches. Notice there's parentheses because the whole thing is inches. You really didn't need the parentheses that much, because we know, unless you kind of read it as 14x subtract 2 inches, I think that's the issue that we're trying to avoid. So in other words, if I tell you x is 5, you could find the perimeter. Or maybe I tell you what the perimeter is, then you'll have to solve for x. But we're not going to solve for equations just yet. Again, that formula is for rectangles, parallelograms. Perimeter is add up all the outside, I always say outside numbers. Hey, all right. So again, you've got a quick set of notes that we just did and a quick assignment. All right, be awesome.